What I've got here is a kind of an innovative trellis for growing hops. It may not be commercially successful, but I think technically it's worked out. Normally hops are grown as poles that are 24 feet high. Here, these tallest poles here are only 16 feet. So they're 24 feet up and they're made with wire rope and all sorts of things. It's very difficult to imagine a single person, especially an old fart, doing something like that. So I happened upon books about a Japanese design tradition called Wabi, Sabi, which is about imperfection and impermanence. It's a Zen way of looking at things. And I looked around my hop yard and I thought, well, I've got imperfection and I've got impermanence for sure. So I kind of adopted it. And what I built was a trellis that looks like this. You can see that this is a 1 foot square nylon netting, and I buy this in 1,000-foot rolls. And then I've got it kind of hanging up on bamboo poles. And the bamboo poles themselves are adjustable with various kinds of pulleys and rigs around and about. So if we walk up higher up, you'll see what this looks like. There's this row, and there's another one farther on, 10 of them. They're linked together up above with a small rope. You can see here that sort of just ties one vertical pole to another. Doesn't take much stress, it's just enough to keep them registered to each other. And then that whole matrix works all the way across the trellis, hopefully making it a network. It's very windy here, so things need to be able to not resist the wind, because this stuff's just not strong enough to resist a 50-knot wind. So they need to let the wind blow them. They need to be elastic. And what I found was that the ropes I was using were great, except that they didn't have a kind of a good reaction to a snap load, like when the wind blows the trellises over. So I've had to add pieces of nylon rope to get some stretch in it. It's woven into the black nylon webbing, and that's what holds the whole webbing up. And that manila rope is supported on the bamboo poles all the way down the line. And down at the other end, you can adjust that for tension to hold the net higher or let it down again for harvest. So the whole intention is to provide something that's cheap, simple, as organic as it can possibly be. It kind of replaces labor maintenance with capital costs, so I don't mind putting the trellises back up as long as it saves me a few $1,000 in steel and wire. And there's integral irrigation. Each line has got a drip row running underneath it, so I water only the hops. I don't sprinkle and waste water on the other things. So I can water the hops quite deeply, and I will irrigate and fertilize the hops also by putting fertilizer through that pipe at the same time. And that'll give me a fully self-contained system. It should be that you could take 2 of these trellises and put them anywhere in the world, anywhere in any kind of a desert environment. It doesn't matter what the countryside looks like underneath, and they're self-contained, they're self-sustaining, they stand up, they reinforce each other, and with the irrigation together, they provide pretty much all you need, irrigation and nutrients to the plants. All these angled ropes, that's what holds these vertical posts straight at this end, and they're adjustable with a pulley here, so you can keep them vertical, and then the rope that goes across the top of the trellises is attached here, and it's likewise adjustable. There's only 10 rows. There are 10 different varieties of hops in here. The intention is to see which ones do best in this terroir, because this is a southwest facing 5 to 10 degree slope facing straight into the desert, no shade, no nothing. So when plants say full sun, this is full sun. This is the fullest sun anywhere in Canada, right here on this piece of ground. So it's going to be interesting to see which of them, with minimal horticultural work, because I'm not doing that, actually survives and produces. And maybe we have a sort of a desert cultivar of a hop plant that's going to just get back out to its roots out here. They say that if you take plants like these that are intended to make resin, if you make the plants really work hard, then they make the kind of the juiciest buds. Same with marijuana, same with oregano, same with any lavender, any of these things that you want to get an intense, concentrated product out of. And then they're a little tiny bit pre-processed by going through the machine. Because this is a hugely labor-intensive process. And this gathers them up. It'll be really easy to separate them, bag them, label them, the whole ball of wax. So we bring in our hops in our hop vac, we call this. It used to be a shop vac, now it's a hop vac. And every time we do a batch, it's a particular section of a row. It goes into a box, they're all weighed and labeled. Then they're stacked up here in this array, and this is sitting in front of a large blower. All of these boxes have open bottoms. So the air is forced through all of them, and that dries them. The standard procedure for harvesting hops is to pick them and pick the whole bind and then put them in very large picking machines that run the whole bind through. They're $1,000,000 machines that pluck the hops off. Then you dry them all, more big industry. Then you compress them, bale them, and then you ship them off to an outfit that pelletizes them, and you make these little hops pellets. And that's the industry standard. Well, the capital costs of that are in the millions, even without the pelletizing plant. That doesn't make sense for me here. So I wanted to find some way that I could process these hops and add value to the process rather than just trying to sell an ordinary product. Because it's a very small place, so I have to add value to make it feasible. So this is a big tank of liquid carbon dioxide here, and it's plumbed in to the inside, and I'll show you the little extraction machine. So this is just a hop processing machine. That it's an extractor that I got from folks in California at Friendly Farms. And what we do is we inject liquid carbon dioxide from that big tank through this rotating nozzle in here. Then you take a filter. There are different grades of filters of different fines. You put a filter over the top of it like this. Then you put this cone on top of that, and it just clamps on. It's a very simple machine. So I have one screen here on top of this now, and I've got another screen that I've attached to the top. So this one is a little finer than this. So what I would do when I'm running it is I'll open this up and put in some liquid carbon dioxide into the tank. Make it go. Inject liquid carbon dioxide for about 10 to 15, 20 seconds. The liquid carbon dioxide comes into the tank, and carbon dioxide can only turn into, it can't go to a gas from its liquid. It has to go through a solid phase first. So it makes dry ice. So the liquid sprays out of there and it makes dry ice. And dry ice is at about minus 79 degrees C. So the temperature inside this kettle becomes minus 79 degrees C in seconds. The frost just blooms outside the kettle. So I rotate it for some period of time. And all that yellow powder just crystallizes out of the frozen vegetation is what happens. And the gas pressure eventually pushes it through that fine screen and into the neck of this contraption here, where at the end of the run you take the neck off and it's full, sometimes a quarter of an inch deep, all the way around the inside of this with hop hash, which looks like this. So this is a concentrated pollen of the lupulin glands. And this is last year's, it's not fresh. This, when it goes into a brew, is much more efficient than putting all that vegetation in from the pellets. Number one, you're not putting the vegetation in, so you don't have to take it out again and what the brewers call, I think, the trug, the waste vegetative material. You can put it in right at the end of the batch because it's just flavoring, that's all hops is, and you can tailor it precisely to whatever you want to add to your beer. This is a very small scale, very low cost hop facility. It's intended for one person or a family to be able to operate and make enough money to pay for the place and kind of live on. And so if we can do this small scale agriculture with appropriate technology, fully organic, minimal interaction with various things, and just keep it simple and make a good product that brewers want to put in their beer, I'll be a happy camper. So that's what I'm doing.